pass through. So the authentication is pretty much the same. I mean, the files are in a slightly different place. So I've decided to organize things a little bit differently in this project. So under user, I've got the auth folder, and that contains all of the auth information. So it's reorganized, but it's exactly the same. So we have the auth service that is responsible for either creating a token or validating the user. And again, that uses the JWT service from Nest.js JWT. And then there's a validate user function, which given an email address will find the user, and then it will use the encryption service to compare the plain text password with the password that's encrypted and stored in the database. So then that's used by the local strategy. So inside this validation, so we use the auth service to validate the user. And then if that user doesn't exist, or we don't get anything returned from that value, then we throw an authorized exception. But then if everything is okay, then we return a user. So then on the request object, there'll be a user, which will correspond to our user. So another thing I did slightly differently is before I was using Neo4j nodes inside the application. So what I've done is I've used entities instead. So I basically created, in this case, a user entity. So the user is basically just a simple class which takes the Neo4j node in, and then gives some helpful functions there to either get information, so the ID or the password, for example, or to convert the record to JSON. So that's something that's called by the controller. And yeah, so if we look at the local strategy, so another thing I had to do to, and this is kind of a weird thing that you have to do, because the information that comes through in the login request comes inside a user object. You have to supply so you have to basically split the dots with these square brackets. I couldn't quite find out why that was the case, but essentially what we're saying is from the user object, get the email for the username, and then for the password, get the password field. So that's extracted by this passport strategy from the request, and then gets added to or gets passed through to this function, which then validates the user. So that was kind of a weird thing, but once it was done, it was done. Cool. So in terms of the register request, so essentially it's a post request to the API URL/users. So what I did there is I created inside the user module, I created a users controller. So this has a method for posting to the index, and again, just as it is inside the Neoflix application, this takes a user DTO. So the user DTO is slightly different again. So because the user information is sent inside this user property, so rather than it just being the actual payload itself, there's a little bit of extra configuration that you need to do in the DTO. So basically, web inside Neoflix, you've got this DTO, and that's what you would export. Basically, what you need to do is you need to say instead that for this create user DTO, you want to validate the nested object, which has a type of the user DTO, and then we say that the user is then that user DTO. So the validation gets done on the nested value rather than the parent value. so the user's controller. So basically, what we do is we take that create user DTO and then use the user service to create the user. So again, this instead of using the create user DTO dot something, it's the dot user dot something, just because of the way that request comes in. And the user service is the same as it would be in Neoflix. So inside this create method, we've got the username, the password, the email, the bio, and then the image. That's the information that's required by the UI. And then we just use the Neo4j service to send a write query to Neo4j. So we're essentially just saying that to create a user or a node with a label a user. And then the property, so the ID is a random UID, so I'm using a cipher function there to generate that. The username should be the username that's passed through inside the parameters. Same for the password, the email address, the bio, and image as well. If everything is successful, then we take the records and then use the first record and then the U, so the return U there, to create a new instance of the user. Then the auth service will then create a token. So again, this is just using the JWT service to sign the claims for that user against the secret that's configured earlier. So inside the user entity, I've created a get claims method, and this just returns all of the information that is relevant for the user. So it's the kind of information that we can use to customize the front end. So we take the username, email, bio, and image from the node's properties, and then return them back. So in terms of the username, we've renamed that to be sub to follow the JWT conventions. And then for the image, if there isn't an image, then we return a 200. And then that will get signed into a token, and then we return that as the user. So we use the spread operator to spread all of the values from the user, and then we append in the token as well. So the reason for doing that is in the login request. In the register request. Inside the test itself, we can see that all this information is required. So the user has to have an email, a username, a bio, image, and a token as well. So if I update the environment variables, and then we call this Twitch. So now that will be applied for every one of the tests. So what I can do is I can just run the register query, and then I should get a response. So first I need to start that. So npm run start dev. Cool. So this error here, so could not perform discovery, no routing servers available. So that's because I haven't started Neo4j yet. So if I go into Neo4j desktop, then I've created a new database here called Real World. So it's using Neo4j 4.1.1. So I've got some data in there at the moment from my test previously. So we just wait for that to start. That I haven't covered before. So this is something I made in the background to the Neoflix project, is to create this error filter. So basically, one of the issues that we had before was to So one of the issues with the previous API is that if we sent the message the request through for a first time, then everything would be okay. Then because we created constraints inside Neo4j, Neo4j would throw back an error, and then basically that would cause Nest to return a 500 error rather than a bad request error. So instead, what we should be doing really is returning a bad request error to the front end to basically inform the UI that the value has been taken. So in terms of the user, so there are a few things that should be unique there. So inside the user service, if you see the kind of things that are being queried on, so the user is queried by email address, and is also looked at by username as well, further on down the line. So that really needs to be unique, otherwise we'll get too many rows. So if I take a look in the database, cool, everything is running. So there's some data in there at the moment. So there's some test data. So I've got a user and a couple of users there at the moment. So if I just clear all those out, for now we don't need that data. So basically what we want to do is we want to create a constraint on user and then assert that u dot email is unique. So there's one already existing there, which is good. So we also want to say that the username is unique, and we want to assert the ID is unique. Cool. So then if we run this this test for the first time, everything should be okay for the register request. So this is the information that's come back. So we have this user object. So it's got the image, the bio, the ID, email, and username. So that's all the information from that to.json method. And then it's also got this this token as well. So if we take a look at that token, then you should be able to see that the information has been correctly set in there. So the sub is Adam, so that's the username that I created. The username is Adam, email adam@neo4j.com. The image is the default image. We have the issued at time, which was a few seconds ago, and then the expiration time. So that is 30 days. So that's basically based on the value set in .env. So that's 30 days there. So when I created the JWT module, I registered the JWT module. I set that as a parameter inside there. So that's the first time that ran. So to illustrate the this filter and what this filter does. So if I comment out for now, and then run the request again. So because this this email won't be unique for the information that's being provided. So right now I get 500 internal server error. So you'll see here that the exception that's been thrown is a Neo4j error. So node 1 already exists with the label user property email adam@neo4j.com. So obviously that's a bad thing. That's going to lead to sort of bad user experience in the front end. But what this filter does is essentially it will filter the responses and filter the errors. If the error matches a Neo4j error, so the error that's thrown by the Neo4j driver, then it will handle it appropriately. So if I go into the Nest Neo4j repo, then I can show you what's happening there. So the filter. So basically, this is decorated to say to catch a Neo4j error, and then if that error is thrown, then this should be caught, and then it should respond, or should intercept the response. So basically, I take the from the context, I switch to HTTP and get the response. So by default, what we send is a 500, an internal server error. But basically, what we're going to do instead is turn it into a bad request error with a status code of 400. So that mimics what happens in the validation pipe. So both of the constraints that we want to handle are the exist constraint, and then the unique constraint, and then the exist constraint. So the only way to work out the difference between those two is to pull the information from the message. So you can see that the it's gone. So the error that was returned basically says, node already exists with a label. So we can say that if the actual message includes already exists with, so that's the bits that won't change, then we can say it's a 400, it's a bad request. And then we use the message to mimic the response from the validation. So that is an array of strings. So we can say that for example, like a property is already taken. In order to get that property, we can use a regular expression match. So the information that's important in there is the user, the email, and property. So basically, we want to say like email already exists. So we can say that by matching on anything in backticks, so either for example the user or the email, then we can pull that information out. So the first one we're not interested in, but the second one is going to be the property. So we take that and use destructuring to destructure the array. And then for the message, we say replace the backticks or all of the backticks inside there. So that's a global filter. And then it will say basically email already taken. If it's an exist constraint, then the message is slightly different. So must have a property. So the code inside is the same thing again, just the only difference is that should not be empty. So we take that response, we remodel it, and then we set the new status code and the JSON to return. So then the output here is email already taken, exactly what we want to do. So that's the filter. So we can see that this works in both senses. So next on to the login request. So the login request again. So that's inside the auth controller. No, sorry, it's in the user controller. So it's to a post request to /user/login. So this uses the local auth guard. So again, like the Neoflix example. So the auth guard then takes the strategy. So again, we need to do the some configuration to extract the email and the password, so the username and password. So that's the same there again. So once that information has been extracted, it then gets passed through to this validate function. If so we take the username and then the password. The responsibility of that request is then passed on to the auth service to validate the user, so passing through the username and the password. If nothing is returned from that function, then we throw an unauthorized exception, so that the username or password is incorrect. Otherwise, we return the user. That user then gets appended to the request. So then we can use the request.user to then pull the user out. So if I run that test, and we can see that all information is there. So there's 6 tests on this one. So the response should have a user. That user should then have email, username, bio, image, and token. So all that information is there. And as part of this test, then or as part of this test, then that information will be stored into the token. So then the next test is the get user, and what this should do is should return the information about the current user. So the basic login flow is, if we take a look at the user controller, so anything like /user goes into here. I've added a guard to the whole of this class. So basically, any request that comes into this class wants to get through to any one of these root handlers will have to go through the JWT auth guard. So the auth guard is basically an auth guard which then implements the strategy, and then exactly just like Neoflix, we want to pull the JWT token from the request, and then we want to check it against this secret key. So the strategy will do that for us. So the passport strategy from Nest.js passport, it'll extract that information and then pass it through to the validate function. So that payload there. So then what we can do is we can use the email from the payload to then find the user in the database. So inside the user service, we have this find by email method. It's basically just runs a read method against Neo4j to return the user. So it will look through the database. If it does find it, it returns a new instance of a user entity based on that node. And then if it doesn't, then it returns false and then doesn't get through to that the validate method. And then again, so what happens is because we have this user here, that user then gets assigned to the user property, so that on the request, then we can use that as we go forward. Cool. So if I run that request, and we'll see that whole flow is taken effect, and then we basically get the user returned with the information. So that's using the 2JSON method. Cool. So another thing that may be interesting from this Nest Neo4j project is the concept of an interceptor. So if we take a look at the definition of what an interceptor is on the Nest.js docs. So basically what they do is they are classes which are annotated with injectable and then implement the Nest interceptor interface. And what they do is they will either bind logic before the execution of a root handler method or afterwards. So for example, what we can do is we can, when a request is coming in, we can modify that in some way. So for example, like an auth guard would be an example of this. Or when the response goes out, there may be some sort of manipulation that we want to do in order to do that. So there are two interceptors inside this project. So there's the type and the transaction. So for the first instance, we'll take a look at the type. So I've used this throughout the application. So if we take a look for the type interceptor, so I've used it inside the article controller. So I've used this on the throughout the whole of the class. So everything in the class will have this interceptor, and then basically what the interceptor does is it will take a responsive request. So this intercept method here So it will run the next call handler. So it will basically run the request, and then it will basically uses RxJS to listen to the response. So we're basically piping the response into a map operator, and then so essentially what it's doing is taking the data and then converting it to a native format using using this function here, which is a little bit further up. So in order to demonstrate this, so if I first create an article, cool. So it's creating this article. So how to train your dragon, bodied very carefully, and again that's passed the test. And then if I go to search for the articles, we just get a list back with one at the moment. So there are a few things inside this value which are interesting to look at. So for example, the created at and then the updated at. So right now these are ISO dates. But when we create the value inside the article, so there's a few things that we do. So for example, we create when we create an article, we take the values and then we just append them into an object, which then gets appended to the node. And there are a few things that are created. So the UID is a string. We also have the created at and updated at properties. So these are set to the current date time in Neo4j. So to illustrate what this does, if I go into the article controller and then I remove that interceptor, then the response is going to look a little bit different. So, for example, so we've now got this articles count, so it's got a low and a high. So I explained this in one of the previous sessions, but so there's basically a disparity between integers in Neo4j, so a 64-bit integer and then the 32-bit integer, which is used with the Neo4j JavaScript driver. So the way that the driver works to get around that is that it will basically convert the integers into a Neo4j JavaScript integer type. So there's this function for converting that, and then that basically creates an object with a high and a low. You can see again with the created at. So because this is a Neo4j date object, everything is split out into the different values, and then those values are integers in themselves. So what that interceptor does is it basically looks for any values, for example, something that is a date or a date time, and then calls a method on there to then convert that in. So for example, for everything that is an int, then we return value.toNumber, and then that will either convert it back into a JavaScript integer, or if it's too large, then it will convert it into a string. So if I enable that again, and restart the server. So basically what happened is now, before the response is sent, all of this information will be converted back into its native format and then returned. Cool. So now I can see there are strings there again. So for the article count, that's now an integer rather than an object with a high and a low. And then all the information is there. The other interceptor, which is interesting, is the Neo4j transaction interceptor. So I've not found a use for this yet in the real world example, but instead this is something that will be useful and will be used inside Neoflix. So, for example, in the Neoflix login flow, we use two different services. So we have a service for creating the user, and then a service for creating a subscription for that user. So then that logic can be reused. So what happens is, so essentially, so before the as the request comes in, the interceptor will basically intercept the request. It will use the Neo4j service to then create a transaction and then assign that transaction to the response. To the request. When that is then handled, so the request then gets handled, gets executed, and then the request is then piped through to RxJS operators. So basically, what this is saying is that we use the tap function, so basically just to run something without affecting the RxJS stream. And that will essentially just commit the transaction at the end of the request lifecycle. If anything goes wrong for any reason, then the transaction is rolled back, and then the error is rethrown. So if anything does happen, so for example, the unique constraint error is thrown, then that transaction will be rolled back. So this is really really useful when using it in terms of services. So if we take a look in the article service. So one thing I've done is I've changed the scope of this this service. So in terms of the scopes, so by default everything is a singleton, so there's a single instance of that class is provided across the whole application. So if you change that to request, then a new instance is provided exclusively for any incoming request. So because a lot of the functionality that works around the article service involves the user in one way or another, it makes sense to inject this in, and then you can. So by changing the scope, you can then inject in the request, which will then give us access to the express request. And then that gives us access to, for example, the transaction, which is created by the transaction interceptor, but also access to the user that's been authenticated. So, for example, when I create an article, I find the user based on the user ID, and that uses the user which is pulled from the request, and then that get ID function to pull the ID. Again, so there are some methods as well. So, for example, with the articles, there's a favorited, and then there's a so a favorited property on there. So that is basically saying, has the user favorited this, yes or no? So if, for example, I favorite an article, then that favorited is then set to true, and then the favorite count is updated. And then if I unfavorite, then it will convert that back to false. So if we take a look at the method for that, so it's inside the articles controller and it's favorite. So that would be post favorite. So this uses the article service to then run the favorite method based on the slug. So I've only passed through the slug there, which comes from the URL. So we've already got the user as part of the request. So basically, I can just take that user, extract it from the request, and then use the ID inside the query. So I match the article based on the slug, match the user based on its user ID, merge a relationship of favorited between the user and the article. and then return some information around them. So because this is a conditional thing, we have this case statement here. So we can say that that if the these ID parameter that's passed through is not null, then we check to see if it's if there's a relationship between the user and the article. Otherwise, we just return false because a user that hasn't logged in isn't going to have favorited the article. So that's really useful and should save some time. So like I say, all this is available. It's up now. So version 0.1.1 is now up on npm. So you can just use npm to install it. I'll be updating it as and when I go. And then you can use it to basically speed up your Nest.js development. So I work all the way through from through the auth, through the articles, and then the favorites, comments. So I did those 3 groups in about 6 hours. So the actual Nest framework really helped with that. So I've not done these yet. But as my computer is overheating at the moment, I'm going to leave that till next week, I think. So yeah, it gives me something to do next week. So yeah, thanks a lot for everyone who's attended for the last 50 minutes. Thanks for sticking with me. Tiago, really sorry that you're facing some issues there, buffering and flickering. It probably is on my side. It's a hot day today in the UK, and my computer is overheating. But all of the code to the series so far is up on GitHub. So if you go to my GitHub, Adam-Cowley, then you'll see all of the repositories there. So there's the Twitch project, which has the Neoflix example from start to where we are now. If you're interested in the integration of Nest into Neo4j or Neo4j into Nest, then you can go to the to Nest-Neo4j and you can install it from there. The code is being updated often. If you have any comments, if you have any requests, feel free to get in touch with me. I'm Adam Cowley on Twitter. I'm Adam-Cowley on GitHub. Feel free to open up an issue. If you want to fork the repo and create a pull request, then feel free. Otherwise, enjoy the rest of your day, and I'll see you this time next week. Take care.